Okay, what you're about to see might seem like it makes absolutely zero sense at first, but you gotta stick with me because by the end, you'll get why this could be a total revolution for computer graphics, for movies, for video games, everything. So let's just dive right in. And hey, I'm not the one exaggerating here. That is a direct quote reacting to this research. What we're talking about is a technique so powerful and so fast, it's almost unbelievable. But it all starts with this really, really strange question. I mean, seriously, think about that for a second. You have a photo. Why on earth would you use a ton of processing power to make an exact copy of that same photo? It seems completely pointless, right? But believe me, solving this little puzzle is the key to the whole thing. All right, so let's unpack this whole process of perfect duplication. It kind of feels like a magic trick, where the magician shows you something totally ordinary, only to reveal this extraordinary secret a little later on. So you've got this team from some of the biggest names in graphics. We're talking Intel, AMD, NYU, and they decided to take this brand new cutting-edge 3D technique and do something nobody expected. They pointed this incredibly powerful 3D tool at a simple 2D image. And what they got was, well, a perfect copy of the original. But the really crucial part here is how it was made, with just blinding speed. Now, we're still kind of in that why are we doing this phase, but the what is already pretty incredible. Okay, so how does this magic actually happen? The official name is Gaussian Splatting, but honestly, a much better way to think about it is like unleashing a swarm of tiny, super efficient paint fairies onto a digital canvas. The core idea here is just fascinating. Instead of building an image from that same old grid of pixels we're all used to, Gaussian Splatting uses tons and tons of tiny, colorful, semi-transparent blobs. And the way the source describes it is just perfect. It's like shining a flashlight through a cloud of dust to create a picture. And this breaks it down so well. First, the algorithm scans the original picture and finds all the important edges. Then, it drops in a few of these Gaussian blobs to get started. And here's where the magic happens. The system starts massaging them, stretching them, moving them, changing their color, over and over until, bam, you have a perfect match. It is an absolutely beautiful process to watch. And when I say this is fast, I'm not kidding. This isn't just a little bit better, it's a massive leap. The entire repainting process happens so quickly that in the original research video, they actually had to slow it way, way down, just so our human eyes could even see what was happening. Incredible. Okay, so we have this beautiful, ridiculously fast algorithm for recreating an image that we already have. It's time. Let's finally solve this puzzle and reveal why this is such a mind-blowing game changer. Let's just ask the question one last time. We start with a picture of the Curiosity rover, and we end with a picture of the Curiosity rover. Why go through all this trouble? Well, the answer isn't in the final image itself. It's in how that image is stored. And boom, there it is. That's the whole point. The new image, the one that's made of all those tiny Gaussian blobs, is stored in a file that is 25 to 40 times smaller than the original. This was never about just recreating an image. It's a completely revolutionary way to do image compression. But to be the champ, you gotta beat the champ. So the real question is, how does this thing stack up against JPEG? The undefeated king of image compression for over 30 years? Let's get to the moment of truth. Just look at this comparison. For basically the exact same file size, we're talking 160 kilobytes versus 159, the quality isn't just a little better. It is, and I'm quoting here, way, way better. It's so much cleaner. There are none of those ugly, blocky artifacts you see in the JPEG. This is just astonishing. So what does all this mean for us? For you and me? This isn't just some cool paper for academics. This really points towards a sharper, faster, more efficient digital future for all of us. This is the real takeaway. I mean, imagine a world with razor-sharp, perfect images and graphics everywhere you look, but they're stored in tiny little files that load instantly. That's the future this technology is promising. Instant, beautiful graphics accessible to everyone on any device. It really is a beautiful algorithm, and it's hard not to get completely excited about what's possible. It just makes you kind of step back and think, wow, what a time to be alive.